Hello and welcome to today's lecture at Pune International Center. I am Abhay Vaidya, Director, PIC. The Indian Space Research Organization is one of the most outstanding and inspiring establishments in the country, which has used space technology rather spectacularly for national development. ISRO has made this contribution over the last 50 years, and there is perhaps no parallel example in any other developing country of an organization like the ISRO. Our guest speaker today is Dr. Deepti Deobagkar, Chair Professor ISRO. She will be speaking to us on societal applications of space technology. Chairing today's event is the renowned defense scientist, Professor Amitav Malik, Padma Shri, and Trustee PIC. Dr. Deobagkar has been associated with the Savitribai Phule Pune University for more than 36 years. She taught in the zoology department from 1986 to 2017, was professor of molecular genetics from 1998 to 2017, and is ISRO chair professor since May 2017. Dr. Deobagkar has also served as Dean, Director of Bioinformatics Center, and Head of Department of Zoology and Microbiology. She has been a task force member in the Ministry of Earth Sciences, Department of Biotechnology, and the National Scientific Advisory Committee. She was also a consultant to Serum Institute of India for 12 years. Among her many awards and honors are the INSA Young Scientist Award in 1989, Department of Biotechnology's Women Scientist Award for Science Popularization in 2004, and the UNESCO World Academy of Sciences Fellowship, among many other fellowships. Dr. Deobagkar's research is in the area of adaptation and epigenetics, and she has been developing innovative approaches through her multidisciplinary expertise. She has published more than 100 research papers in national and international scientific journals and has guided many students for MPhil and PhD. Dr. Deobagkar, welcome to this program.
Thank you.
Professor Amitav Malik, the chair for today's session, has been a defense scientist since 1966 and is credited with developing indigenous lasers for defense applications. As the founder director of the Laser Science and Technology Center, New Delhi, he pioneered high-power lasers for satellite defense applications and was honored with the Padma Shri in 2002. Professor Malik has served on the National Security Advisory Board. He has authored 6 books on technology and security issues, and presently he is a trustee at the PIC and heads the Energy, Environment and Climate Change Research Vertical. He is also the Programs Committee Chair of the PIC. Professor Malik, thank you very much for chairing this event. I would like to inform our audience that today's session has a Q&A segment, and you are welcome to post your questions in the question box. May I request Professor Malik now to present his opening remarks. Over to you, sir.
Okay, namaskar everybody. And this is a unique kind of a talk that we are organizing today, where the speaker is a well-known scientist and sociologist who has looked at the application of technology for social applications and social cause. And I am ex-defense scientist who has looked at the same technology, but from the point of view of national security. It's worthwhile noticing that among all the spacefaring nations today, which are quite a few now, all of them have started activities in the outer space exploration out of security concerns. India is the only exception where we started the space exploration, satellite technology, everything else, with an agenda which was not military. In fact, it was more reaching out to the public, communication, education, and so on and so forth, which is what I'm sure we'll hear from Dr. Deobagkar today. But at some point, the thin line between the sociological applications or non-defense applications and the defense applications, the line becomes very thin, because the outer space is a completely open dimension today. It's controlled by the treaty. At the same time, the treaty does not cover many other things. So we have been researching to see how the treaty can be either strengthened or modified to address the security of the outer space. And that security of the outer space is more important for societal or civil applications of space, which should not get disrupted because of the military interests of other forces. So in a way, the speaker today is ideally suited to talk about the issues and the applications that a person like me has been trying to protect and promote. With this, I think I'll request Dr. Deepti Deobagkar to share her thoughts with us. Over to you, Dr. Deepti.
Thank you. Thank you for the kind words. Let me just share my PPT and just let me go to the first slide. And can you see it?
Yeah.
Okay. So I'll make it full screen, right? Give me a second.
Yes, please.
Yeah. Okay.
Correct. Good.
Yeah. Shall I begin my talk? Yeah.
Please.
Thank you so much for giving me this opportunity to talk to you about something which I find very interesting and exciting, and that is the societal applications of space technology, which our Indian Space Research Organization, with a large number of other organizations, has been developing. I'm going to discuss the societal applications. So let's look at how it all began. So most of you may be aware of it. And one of the motto I like about ISRO is it says, "Is sky the limit?" So just to quickly run through, in 1963, from the Tumba Equatorial Rocket Launching Station, or TERLS, the first sounding rocket was launched. However, the discussions about initiating a space program in India began as early as 1961. And as we know, ISRO was established and started on 15th August 1969, and Department of Space in 1972. You know, these are in a way very famous pictures, and they just remind us of what an humble beginning ISRO has had. And you know, they started their work in a tent, and these are satellite parks being carried in the early times on a bullock cart or on a bicycle. Okay. Now let's just see where we are today. That the Indian space mission over last several years has made enormous contributions and placed our country in the 3rd or 4th rank. Not that we are in any competition, but it has made us very proud. So there are actually 114 spacecraft missions, 3 nanosatellites. We have had 83 launch missions. The earlier launches were done from other launch pads. What's very interesting is we've had even 13 student satellites. And for Gaganyaan, this is very important, we have had 2 re-entry missions. And 342 foreign satellites from 34 countries have been launched by our space organizations. And what do these satellites do? Because normally we think of satellites and rockets as just going in the sky and going around. But very often, many of us do not appreciate that they are playing such an important role in communication, navigation, Earth observation, climate studies, planetary observations, and many other aspects. Just a glimpse of a few of our satellites. That's Aryabhat, that's Kalpana, Chandrayaan. This is the launch pads from where the rockets are launched. And just some pictures for you here. You know, this is a satellite image which has been generated from what satellites has observed there and then connected it. And this is the high-tech city of Hyderabad. And I've also picked up here the Jammu and Kashmir floods. Now, we are not going into the details, but you will imagine that it's possible to get very high resolution in detailed pictures with a whole lot of quantitative data, and which are extremely useful for a large number of applications. Since I have focused my talk on societal needs, and the scope of this subject is very vast, I just thought let's remind ourselves what are the basic societal needs. So I would say water, food, housing, environment, good health, and a few other things like safety, transport, education, security. So you will be, as we go along, I'll try to highlight that for water, we have had a water body information system. For food, ISRO has developed Chaman, Fasal, and many other programs. We can do pollution monitoring, but we'll go along and see what are the applications as such. So ISRO has a main motto that space technology in the service of mankind. And our missions are very economical. In fact, if some other countries have already launched missions, then we have complemented those expertise and got very specific special data from our payloads and sensors, and a galaxy of applications in all walks of life. And peaceful use of space technology, as I mentioned, I'm repeating, is the main motto here. Obviously, we have Dr. Malik, who is an expert in the defense securities. I am not going to touch upon it today. These satellites and rockets which are sent in the orbits, some of them are orbiting around the Earth at 36,000 kilometers up in the sky. And very rightly, they can be called as eyes in the sky because they are constantly observing the Earth as they go around in predictable orbits, right? So this is Indore, the picture of the Volcker Stadium. Again, not a photograph, not a drone picture, not from aeroplane, but a satellite image. And this is part of town planning studies. So when these kind of imagery can be used for town planning. Again, this is a fascinating image. I would say this is a Kumbh Mela picture, but again generated from data and images and all the information obtained from satellites high up. And again, this maybe one can go on a drone and take picture, but if one wants to study glaciers, which are spread over a large area in Himalaya, and you want to look at forming of the glacier, some problems with it, all of this can be studied and monitored through ISRO's satellite imagery, data capture, and analysis protocols. Okay, I'm just trying to give you a scale and scope. Look at the galaxy of Indian remote sensing satellite that we have here, and like INSAT and ResourceSat and Megatropics and so on. And the applications that these satellites can have are like, for example, communication satellites will be very useful in telecommunication, radio networking. All the television that we get to see is also through the satellite network. There are certain programs on navigation and Earth observation satellites which are linked through these data sets which are called as Gagan, or GPS-aided Geo Augmented Navigation. And this leads to a lot of fuel saving for airlines and capacity enhancement for airport and space. And then we have the Indian regional navigation satellite systems, sometimes on their own and in complementation with other satellite imaging systems. They do a very important and critical work of disaster management. They can monitor vehicles and they can integrate with mobile phones. So what I will do in my talk is that I will touch upon a few of these applications in a little more detail and take you through the vast array and the diversity of applications which these satellites offer to us. As we know, agriculture is the primary resource. And 58% of India's population, in fact, 70% of rural population is involved in agriculture for their livelihood. So this slide summarizes actually what are the different aspects which are possible using space technology. Okay, so let's look at it a little bit, like land monitoring, crop area estimation, drought assessment, water management, cropping system assessment, soil mapping, moisture, pests and diseases. Most of these aspects can actually be looked at and analyzed. And we have lots of institutes involved in this, ICAR, Malanobis Crop Research Center, and they provide data for at least 15 different crops in a very timely manner, and they're trying to incorporate more and more crops. In fact, the Pradhan Mantri Fasal Bima Yojana also relies on ground truthing as well as the data that is generated from the satellite. Now, from the perspective of women, 85% of rural women, it is estimated, are involved in agriculture. And if we can use all this in an integrated manner, as it's already being done in agriculture, forestry, fishing, it could change lives. They are already being changed, they are already changed, but we can do it in a much more effective and better fashion. In fact, gross value added of this forest, agriculture and fishery is estimated to be about 20 lakh crore in 2021. Just some more glimpses. This you can see that these are the fields. Now I don't have to repeat, this is an image from the satellite data. So you can look at areas which are within the town but nearby areas, or you can do a high resolution mapping of small areas. You know, in our country, very often people have smaller farms. They don't have very large farms. And you know, this becomes sometimes a disadvantage, but by using high resolution satellite data, many of these things can be assessed. And this is, you know, you can actually estimate rust and other diseases also, or you can look at change in forest cover or what fields were there, how is the progress. Now, for agriculture, ISRO has, along with, so what ISRO generally does is they make the protocol, they make the proof of concept, and then they collaborate with the agencies and continue to do hand-holding. And there is a program called as PUZZLE, and you will like this name because PUZZLE we know is KP, but it actually implies forecasting agricultural output using space, agrometeorology, and land-based observations, field observations, or CHAMAN, which is also another nice name. I mean, it's a short form of Coordinated Horticulture Assessment using geoinformatics. And as you know, that fields of the entire country and focused areas are visualized through PUZZLE. And CHAMAN allows us to look at orchards, fruits, horticulture, do the estimation, do the crop management, a whole lot of data collection is possible. So just a glimpse of some applications of satellites and the data generated through this satellite imagery. We can just go through it, like agriculture, water resources, land use, soil quality is very critical. It can also give advice as to when they need to rotate the crops and many other things. Like, of course, forestry and ecology and urban planning can also be supported through this. And you can see that land observations, crop yield, estimating crop yield or crop areas, all of this can be done through the entire cropping season, you know, pre-harvest, post-harvest, mid-season, and so on. So I spent a little time on agriculture because this is such an important area for our country, and combined with meteorology and rain and other forecasting, this can become and is becoming a very powerful tool. Now let's come to another area. You know, we travel such a lot. We often, I mean, I have always wondered when my flight is taking off from Bombay or Delhi, and this program is again has a very appropriate name. The short form is Gagan, which means, of course, Akash, and it actually, the long form is GPS aided Geo Augmented Navigation System. So the ISRO with Airport Authorities of India have actually implemented this project. They have developed and designed it. And this actually is a satellite-based augmentation system of the entire airspace of the country. And it looks at, the satellites are looking and coordinating with the remote sensing satellites on one hand, and the centers of ISRO in India, and also other agencies which are involved in it. What is the primary objective of this Gagan? It is to establish a satellite-based augmentation system for safety of life. And believe me, this is really, really very important. And what can these Gagan aided things do? They help in disaster management, as I've already mentioned, but they can be integrated with mobile phones. There is precise timing. There is terrestrial navigation aid for hikers and travelers can also be provided. And visual and voice navigation for drivers can also be provided. So I would say that we are not still using it to a great extent, but for air traffic, it's being used a lot. For the signals, for railway, for traffic, lot of things are being developed. And we hope that very soon this will be implemented in a much better and user-friendly fashion. That brings me to yet another program called NABI. We know NAVIC is like a Navadi, someone who goes in the sea, from the ocean or sea. So this Indian Regional Navigation Satellite System, it helps in navigation of ships, railways, roadways, and also spacecraft. And it can be used to study geodynamics, and location-based services can be provided. And of course, research and land management can also be done, because you would know very often, because these are very sensitive things and very crucial things. The Indian Regional Navigation Satellite Systems works in coordination with other systems also. And it really makes use of a whole lot of this technology and the satellite imagery. I already mentioned Gagan and NABI, but TV and DTH, mobiles, all of these, the communication is done through this communication satellites. Okay? And meteorological data is also made available. Now I'm coming to a platform which is called as Bhuvan. Okay? Again, a good name, Bhuvan. So it's an Indian geo platform, which is ISRO's platform. I would encourage any of you who is interested to go and search for Bhuvan ISRO. This Bhuvan provides 2D and 3D maps of a whole lot of things. You can even look at data about 20 years ago or 10 years ago, whatever was available at that time, in a multifaceted manner and a multidimensional manner. So it can tell you about forests and green cover, city maps. Here it said 1 meter resolution, but you can have even higher resolution for the city maps, and you can look at water and rivers, clean Ganga, traffic, of course, as we have been seeing. So what you see here is Mumbai, and this is from the Bhuvan, it is available free to everybody. Okay, it is there are no charges. In fact, National Remote Sensing Center and Indian Institute of Remote Sensing in Dehradun, a lot of imagery is available. Of course, if somebody wants high power data, then you have to approach them and get that. So this is the Bhuvan platform, Indian Geo platform of ISRO, which is, you will notice here that there is 2D ISRO, 3D ISRO, disaster management, a whole lot of thematic services are available, ocean services are available. There are also e-governance, forestry, tourism, and all of these data can be used by companies, society, people, groups, government organizations, and it's made available. So, this geoinformatics remote sensing, just to sort of look at what does it do, it allows us to monitor air quality and air pollution. Even quantitative and qualitative data analysis becomes possible. Groundwater, underground water, rivers, floods, wastewater, all of this can be monitored. You can study coal mine fires, and of course environmental pollution, and its evaluation becomes really very critical and important. Let's come to something which is very important for everyday life and for the society and for the agriculture. So, water resources and waste and other water information, its manipulation, its mapping, planning, evaluating, all of this can be done. And look at this, this is a site, this is a thing available on Bhuvan called Water Body Information System. And it gives you detailed maps and also overall maps if you are interested in them. This is, for example, you can see, rivers and how the water bodies and tributaries are there. And this is actually a slightly enlarged image of Brahmaputra Basin. And although we are not looking at the data, it can give you a lot of data about how the terrain is, how the river patterns are changing, how it's being encroached. Whole lot of things can be planned. Even as I say, quality and quantitative data can be obtained. Just imagine that if one wants to study areas and localities like this in Himalaya or in oceans, this satellite data becomes a real boom. I mean, it becomes a very great advantage, because let's say in Pune, Bombay, Delhi, we can walk around and collect a whole lot of data. But when you are looking at large parts of our country, which are not easily reachable, then you will appreciate this even more. And our scientists have actually mapped the glaciers and the rivers and the Himalayan ranges. And it's a very interesting kind of data set available and which is being made use of. So weather prediction and tsunami and floods and all these forecasts and then management can be made available through the satellite. In fact, it is being made available. And MOSDAC is from Space Application Center, and it gives real-time live images of weather forecasting. Many of us actually look at some of these images on the television, but this provides a huge amount of data about meteorological observations, oceanographic observation, early forecast, and early warning system. In fact, there are link-ups with disaster management systems in our country and the whole machinery that is involved in this. Now, let's come to another area which is very sensitive, very important for us. This is groundwater. Okay, so again, I will tell you that for all the seasons, the entire groundwater mapping can be done in global way as well as in specific details and specific ranges. You can see how the things were 5 years ago, how they have changed today. Is there fragmentation? Is there encroachment? Very scientific quantitative data can be obtained. This is also water resource mapping. This is a sensor which has actually mapped water in this particular area. Since paucity of time is there, I can't elaborate in detail. Now, this is another, we hear very many times that there are forest fires or there are fires in agriculture, and these become very important. So this actually is a map of agricultural forest fire at a particular time. And this is, these are small fires in forests. So, ISRO prepares forest regime maps, even tries to identify which may be more sensitive areas, and it, with the help of this satellite imagery and the data, they can give alerts for the forest department, or even they can do near real-time data dissemination, and also they can do burnt area and damage estimations when required. So this is another blue economy. We talked about green economy. We're talking about blue economy. So, about 7 million people live along the coastline. And our coastline is actually 8,100 kilometers. And a lot of people depend on the fisheries. There are a lot of fishermen. And in fact, there are about 45% women are involved in this fishing work. So I should tell you that today and for last 10 years, every day this fisherman can get a potential fishing zone advisory. That is, where should they go in this open ocean so that they can get better fish catch. And this becomes updated every now and then in terms of being improved, telling them where salmon may be available, tuna may be available. You will agree with me that this actually saves a lot of money, lot of time, lot of hardship for people. And these are given in 14 different languages. Okay, they are also told about their location. They are given high wave alert, ocean state forecast is relayed to them, tsunami warnings are given, and they are given through various different modes. And in fact, in many places, there are agencies and institutes which train these fishermen or conduct local workshops to tell them how they should use these advisories with respect to location and with respect to making efficient use of it. And it has been seen that 80% of the time they get very good fish catch if they follow these advisories. Something that is very dear to us from environment perspective, from greenery perspective, and for protecting our environment is the vegetation map. What is shown here is the vegetation map. And all the species are documented. And this is Government of India, IIRS, Indian Institute of Remote Sensing. They have a biodiversity information system. Anybody who is interested, you can please log into it. It has a lot of data. Every tiny dot, every color means something. And it tells you about that location, about the quantity, about the type of plants, and so on. I cannot leave something which is tele-education. And each one of us has experienced the advantage of this during the COVID time, so I don't have to spend much time on it. But you can see that for skill development, this becomes very critical for skilling. Okay, and we can also see the advantages in telemedicine, and we have a lot of nodes which are available for the telemedicine usage of this in telemedicine, and I'll just tell you. So just look at the locations like this, where we are in far off in Himalaya, or we have people who are at remote places, or there are our soldiers who are walking in these areas and trying to defend our country. So many of these places, they may not have, they will not have any medical help nearby. So through communication through the satellite, can they be made better contact? And this is being done all over the country today. A lot of efforts are being done to make at least primary health care available and give them advice and timely help till they can be taken to a place where they can get good, better treatment. This is, somebody who is interested in environment will appreciate this. This is the map of coral islands in Andaman and Nicobar. And this is our satellite, which is called as OceanSat, keeps monitoring our oceans. And this is actually, again, a satellite image. You can see that any changes in this can be very nicely monitored, and you can study them. This is an old picture, but one can look at it, what has happened today, very easily. Something that is again very crucial for society, for all of us in Maharashtra, we are talking about power cuts. This is a geospatial map which gives the energy map. I am giving you static pictures, but on the website, there are photographs, images available, which are real time also, and you can go back and look at earlier data. So all the energy resources of the country, like oil and gas wells, petroleum refineries, coal fields, all of these are available as a data set. And it can helps you to plan your transportation networks and many other things. Solar energy maps are also available. Every day at any particular place, how much of solar energy is available. Those bits of information are also available through this satellite imagery. Now just look at this. This is actually Clean Ganga project. And this is a small area which has been highlighted here. And you again through Bhuvan and this Clean Ganga, whole lot of field data can be collected through Androids and they can be analyzed. And I think now you have got the idea of what I'm talking about. But this ISRO satellites provide a very strong, solid geospatial support with respect to geological information to the Clean Ganga project. This is something which is really, this is an algal bloom in an ocean. You can see that it can be mapped. When it increases, one can study it. And just to tell you that what we see is not only in India. This is a photograph of New Orleans, and you can see that the pollution in this Gulf can be studied or can be looked at if one is interested. The scope and scale of the study is really enormous. The chemical composition can also be studied because we have a lot of sensors like hyperspectral images, we have monospectral images, we have IR. So you can also see one of the applications in air quality monitoring. This is again very fascinating because from space observations, you can do pollution monitoring. You can see what is getting contaminated, how much is being thrown. I saw a photograph once where they were able to even quantitatively detect the compound that is being thrown. It may not be always possible. So then once you know that a particular area is polluted, one can actually visit that area and keep looking at it, keep monitoring it, and also offer some possible suggestions to get rid of it or to minimize it. So I also talked about waste disposal, although I have not shown you any photograph. So please notice here that there are areas which are very bad air quality, and these have been highlighted in red color for anybody to see and appreciate that there is air pollution. Again, every season and any locality, this can be monitored through ISRO's satellites. I must mention here that ISRO works in collaboration with a large number of other government agencies to do those particular things and those tasks. For example, the potential fishing zone advisories about fishery that I mentioned, although they were initially developed by Space Application Center, Ahmedabad, and other ISRO centers. Now, INCOIS in Hyderabad gives these daily alerts. And the same thing with agriculture, Mahalanobis Crop Research Center and ICAR, they use these data sets now for the agricultural produce and other estimation. So there is a very, or I told you that for Gagan, the collaboration is between Airport Authorities of India and ISRO. So this is the way these things are done or worked. Something that is, our India's philosophy is to help others and help neighbors. So a gesture was made on 5th May 2017, where Southeast Asian satellite, which is GSAT, was launched. And it has capacity to do a whole lot of things. But I want you to focus on this, that the data is provided to our neighboring countries, which is collected from, so it's devoted to the neighboring countries being provided with the data that is required for telecommunication, disaster relief and management and so on. And the countries which benefit are Nepal, Bhutan, Bangladesh, Afghanistan, Sri Lanka and Maldives. So it is like, you help your neighbors, and this motto is being kept in societal applications also to provide help. Some of you may be aware of this, that Antrix is an incorporated company. It's an Indian government company. It commercially exploits the space products of ISRO, provides technical consultancy. And this is what I sort of noted, that in June 21 to the Parliament, it was reported that in 3 years, they have launched a whole lot of satellites and generated some revenue and something to be very proud of. Now, just 1.5 years ago, ISRO established a single window, very novel nodal agency, actually in 2020. And what is it for? It's called InSpace, and it's a single window system for companies, small establishments, entrepreneurs, enthusiastic, beginners in the industry to do all kinds of services, right from launching vehicles and satellites all the way to space application. I think by now, from whatever I am saying, you must have appreciated that the space applications, our ability to generate them and use them is enormous. And I don't think we have been able to use it to its maximum extent in our country. So I think as more and more people get into it, it's like a Marathi, we call it charva, or it's like it's like a mission. And if we can then do and use all these activities, ISRO is very actively going to support. It's going to provide infrastructure, and the premises and the space is also going to be generated and made available. There'll be active collaboration with these small, tiny startups or industries. And this is called as opening of the space by ISRO. So from that perspective, this becomes very useful step. And it's a very challenging step because up till now, ISRO used to have a lot of collaboration, but they had not opened up the space. So this has tremendous implications. This is the Satish Dhawan Satellite Center. And, just on a lighter vein, please note here that so many stamps have been produced at different time points to mark those important years. And this, of course, is Sarabhai. And these are our spacecrafts as they were launched. This was a 2 rupee and 2000 rupee note which was launched at that time. And even now, you can see the satellites that are there on some of these notes. If you've not seen, try to look for it. This is, of course, I would like to pay my tribute to Vikram Sarabhai and Homi Baba here. They are at the Tuba Equatorial Rocket Launching Center. These two gentlemen, this is Abdul Kalam and Sarabhai, and this is Dhawan. I could not name all visionaries, there have been many, but I would say that, self-reliance has been a motto for Indian space mission. And we hear some names and so many of them have done great work, but a large number of scientists, technologists and people like us have worked behind the scene in mission mode, putting their best foot forward. And I would mention this statement that excellence is a continuous process and it's not an accident, which was said by Abdul Kalam. I think this brings me to the last part of my talk. right? So I will say thank you very much for giving me this opportunity, and I really appreciate you are giving me this time.
Professor Malik, you need to unmute yourself, sir.
Yes, wonderful. Thank you very much, Dr. Deobagkar. What you have presented is a variety of applications that we take for granted. The very fact that the mobile works, the very fact that the TV works, we don't understand that there is a technology capability that is already established to the maturity where one can take it for granted. And that is what you have brought out so wonderfully. The amount of utility of the space-based technology is enormous. Yeah. And just to say that it's eye in the sky is a very understatement, because it is much more than eye. In fact, everything that is happening on the terrestrial surface can be seen in a totally different perspective by the satellite photos. Our Cartosat series of satellites have got very good resolution. In fact, even for our defense purposes, we very often go for the satellite images for analysis and understanding of the situations. And close to my heart nowadays that I'm in the environment and climate change, a lot of information of the land use, of the amount of greenery that is being lost or being built, will be verifiable only with satellite photography. For instance, we have made a commitment as a nation that we will increase our green cover sequestration capacity by 300% in 10 years. Now, this cannot be verified except by overall imaging. So, low orbit satellite imaging that's available is very useful. Yes, of course, now the drone technologies are coming, so we can get more specific area-specific imaging. But then the enormous application of the Earth observation satellite and communication satellites are so. Thank you for bringing out this, which many people take for granted, and they don't realize how much work has gone into it. And the matter of pride is that this is all our own indigenous efforts. There are very few areas where we have had to take help from the foreign countries, except for maybe the cryogenic engine, which also by now we have developed. So the kind of capacity that we have built in India, in ISRO, and the affiliated infrastructure of industries and SMEs and all that, this is really what we are now talking about, make in India. This is actually all made in India. So that's a matter of huge pride for us. Thank you for bringing out all that. I will just touch upon one aspect and how all this becomes very subjectively dependent on space security. Now, of course, space is becoming an area and a dimension where large powers are trying to garner some capacity for space mining, for space material, for other uses of space. And as of today, I think the outer space treaty is almost under threat, because we can see that our own neighbor in the east is very aggressive about his space. The space explorations are indeed very romantic, very challenging, but there is an undercurrent of the technological capacity that the country has, and that the space flights are a demonstration of the indigenous capability that is already there. So in all, I think today's talk has been extremely useful in terms of, given 45 minutes that you have presented, wonderful bird's eye view of so many things that can be done. What really strikes me as a scientist is how much is taken for granted and how much actually gets done in the behind the scene before the application is applicable or useful for the society, education, but telemedicine, whatever you want to call it. So thank you very much all over again, and wonderful lecture. I'm sure all of us, all our people who participate will appreciate what I'm saying. So I'll hand over to Abhay for any question answer that we may have. Over to you, Abhay.
Yeah, thank you very much, Professor Malik and Dr. Deobagkar. Really a wonderful presentation. The slides and all the information that you provided was so informative. We have a number of questions and many compliments for your lecture. So Mr. Samir Kulkarni wants to know that while India has a very vibrant startup ecosystem, how can startups work with ISRO to use applications for societal use, for societal benefit?
It's an excellent question, because this is what I keep thinking, because the applications in day-to-day life are so many, and I think we are really not able to harness its power. So what is needed is now people who have the capability to jump into it and to take on this matter. But let me tell you how to go about it. If one goes in ISRO in space, and there you will find all the information, the application forms, all the background information. I myself have studied it for last 1.5 years, and I also have been writing something about it. So if somebody is interested, I may be able to help a little bit. But today, the websites are so lucid and they have so much of information, and they have people whom they suggest whom you can reach. So basically, you need to have a company for this particular activity, and you have to apply in a particular way with very focused goals. It may be you want to launch the satellite, or you want to use geospatial technology for fields in Maharashtra or small fields and look at water resources and climate together and provide them help in this fashion. So it's possible, definitely. And they are trying to make it user friendly. It's little new, so it will take a little time to be totally streamlined. Yeah.
Oh, that's wonderful. And if we get any queries at PIC, we'll pass them on to you, and
I will try my best to help.
Yeah. Since you are in Pune and you are the ISRO Chair Professor, I'm sure that would be a big help. And this actually leads us to the next question by Mr. Vilas Rajwade, very much on the lines that you just spoke of. So he wants to know how to use the space applications from ISRO to address school children in Marathi. And I would think he is referring primarily to remote areas, but this is what his question is. If he wants to do something, how should he go about it?
I think today, even the HRD and our government has a lot of programs for reaching, because they have this radio network, mobile vans, and several other things. But, ISRO enables these things and facilitates. So because they are busy in doing these applications, they are not actually in the field in looking at day-to-day things. I mentioned that they partner with some agencies like to do those particular tasks. Now talking about it, I think our CDAC has programs where if you have lectures in some language and you want them to be converted to another language, that can be done. And to reach remote areas, you really need a better telecommunication, which is being established in most places. Like schools are being provided, at least villages, a few places, they are being provided with computers and Wi-Fi and so on. And I think every day it gets better. So I don't know if I have answered your question, but again, I would say you can approach me and I will try to help you. Yeah.
Thank you. Mr. Rajendra Singh's question is about groundwater level monitoring.
Yes.
And he wishes to know, is it necessary to say collaborate with the US groundwater survey department and NASA by using GRACE satellites? Or I would imagine that ISRO is already doing a lot of groundwater survey monitoring. Could you speak on that, please?
Yeah, so actually, if one goes on to Bhuvan and look at resources, they have plenty of resources like water body information system. There you will have a lot of data. If you ask for a particular year, a particular locality, at this depth, you will get all that data there. Now, if you want a high resolution data, then you would need to interact with someone. And for this Bhujal also, a particular government agency will be involved in this analysis. So satellite imagery, making data available, populating these maps, making them quantitative and accurate, is everything done by ISRO. But actually water management is done by the appropriate state or the government department. But there is a lot of scope for people. I'll tell you two systems. One is called as Vedas, visualization of Earth observation data, and another is Bhuvan. These can be used as app also on your mobile phone. They have location services. So I would suggest you can try going through it. And again, there are even not necessarily reach to me, but there are people in this Bhuvan website who will help you on how to go about it, or they are very nice, friendly tutorials to learn how to do it. Okay, this is a very small, I don't have much time to elaborate more, but that's how I'll put it. But the data will be available to answer your question, definitely.
Wonderful. Mr. Rajendra Singh's second question is, could you mention some new applications using nano satellites and LEO satellites that have been done by ISRO?
So nano satellites, are for very specific purpose. The term nano means they are small satellites, unlike our huge satellites that we sometimes have to launch. So for example, one of the nano satellite may be looking at application with respect to moisture in the soil. Or one could make, it depends on what sensors, what payloads are there on the satellite and how they are connecting with the centers on the ground. So if one makes a satellite where you want to monitor rainwater and you have appropriate things integrated on this nano satellite, then it would help you with respect to this. If somebody wants to look at forest, some particular area, and look at application, that is also possible. They may not go at the 36,000 kilometers up, because that may not be required there. You can have a satellite at 700 kilometers or even, yeah.
Dr. Deobagkar, you have been for more than 3 decades with Pune University, and ISRO has been working closely with students. One of the first student satellites that were launched was by College of Engineering, Pune. Could you speak about this collaboration and the opportunities provided by ISRO to students, and say some work going on at Pune University?
So 13 student satellites have been launched already from all over the country. The student satellite which COEP launched was called as Swayam. And but of course, this was actually launched by the ISRO's satellite launching system. So it was complete and made perfect. So now what happens is this involved in training of a large number of students, because the satellite cannot be built in 1 day or 1 year. So they had batches of students which worked like a relay race. Each batch used to train the next batch, and in 2 or 3 years they developed the satellites. So there are very enthusiastic teachers who led this activity. And I would suggest Dr. Khalatkar and others in COEP will be able to tell if somebody is interested in more details. So basically how it works, the funds they need are given by ISRO, our space technology cell, and then they develop and design these. And the cell keeps monitoring the activity, ISRO keeps monitoring. And also hand-holding is done as and when required. Yes.
We have time for just 1 or 2 questions. So I would like, yes, Professor Malik.
I have a 7 o'clock another webinar. So may I say thank you to the invited speaker and take a leave with your permission.
Thank you. Very nice to have you here. Yeah, thank you.
Yeah, I have to log into another seminar.
I understand.
Webinar at 7 o'clock. Yeah.
Thank you.
Okay, thank you very much. Bye-bye.
Enjoyed this session. And
hope to keep in touch. Thank you.
Yes, we will, of course.
So, one question, Dr. Deobagkar, I wanted to ask was, what are some of the new things that are happening?
I somehow can't hear you. Sorry.
Yeah, my question is, what are some of the new things happening at ISRO? Could you speak about that, please?
So a whole lot of things. One is, of course, Gaganyaan, which everyone is excited about. It got shifted, its timeline got shifted also because of COVID, and it's also a very big task. But they have already had 2 re-entry missions, like satellites have gone and come back safely. So that's the most important thing in Gaganyaan. Another thing is they keep designing newer payloads and newer sensors so that our data can be available at much higher accuracy and even not 1 meter, but much shorter distance, few feet and so on, so that the resolution can become better. They also want to this Vedas, which I mentioned, which is developed and designed by Space Application Center. It's a very user-friendly app. You can have it on your mobile, and you can keep looking at any data set that you want to see across the country, whether it's agriculture, whether it's forest, whether it's greenery, whether it's weather. So they are trying to make it more user-friendly. And of course, trying to reach out to more people, particularly with the applications, by getting more and more agencies induced and training people, developing things together. And I mean, this is a little ambitious, but one of the very ambitious projects is called as Aditya L1, which is one day we want to go to the sun. So that is also in the offing. So a lot of things are in plan, interplanetary. Yes, I think that's for the time being.
Could you speak about the work done by ISRO in telemedicine? Now, India is a vast country, and basic healthcare and health services are one of the areas where a lot of improvement is required. So what has ISRO been doing about this? What are the possibilities? What are the achievements?
Yeah, so I think the motto that sky is not the limit is true there. What we can do, if we have again group organizations which can decide to help in this, all this, like a mission mode, it would be possible. But you asked me what is being done. So one of the things again ISRO does is facilitating and making the technology available, developing the technology for easier and better communication, interacting with people to develop, and scientists and companies to develop the kind of apps or tools where the communication, visualization, sending medical data from one place to another, etc., will be seamlessly operated. It won't have any hitches, or even use alternate technology to do that, because some places may not have Wi-Fi, and one may have to adapt some other. But to do this telemedicine, we would need medical experts, we would need social experts, we would need to network the community, make them aware that these things are required. So I can see a galaxy of things that can be done from the society to make this happen in a much, much, much better and effective way.
Right. And your reply is so relevant to the question asked by Samir Kulkarni on the startup ecosystem and societal applications, that if somebody really works with ISRO to develop applications in telemedicine, I think it would be something great for the country.
So I should also mention that ISRO has a program called Respond, and that provides support for research. But you need to be associated with an organization. And developing these apps, I think we have such a galaxy of experts with IT, artificial intelligence, that if they get into developing these apps, ISRO would be facilitator in terms of providing all this data, but integrating it and making it user-friendly and available to people, again, can be done for an industry or for a company. This would have, and ISRO is actually also providing incubation centers. They are setting up incubation centers all over the country, just like other government agencies have. This is a new thing that they are starting. They are setting up labs and incubation centers.
Is anything coming up in Pune or nearby regions?
So I think there are small collaborations, but because we already have an ISRO cell, I don't think there has been anything as yet of starting an incubation center. Yeah, we already have an incubation center in our university, and a lot of other activities related to encouraging entrepreneurs are going on, I think, all across. So yeah.
So Dr. Deobagkar, this has really been a fascinating presentation and discussion with you. We also were very fortunate to have Professor Malik with us. And I would like to mention that this discussion and this recording is going to be available on YouTube for further sharing. We will ourselves promote it among the student community and among the 55 institutional partners that we have, which include the IITs, IIMs, and a number of universities. So with this, I would like to thank you for this wonderful presentation. I would like to thank the members of the audience for their questions and their participation. And I would also like to thank our backend team, Kiran and Amresh Kesre, for providing all the support for this program. With this, I would like to say thank you and a very pleasant evening to all.
Just one word from me. Thank you very much, Dr. Vaidya, and also to Dr. Malik, although he is not here, and the audience. And I can say from my side that I'll be more than happy to interact in any possible way. If somebody who listens to this and wants to get back to me, I'll be happy to do that. Yeah.
Thank you very much. Thank you.
Thank you.